Hello everyone, my name is Stephanie Neal, and I'd like to welcome you to this Automation World webinar featuring an example of an organization that took their SCADA implementation to a whole new level. The Pima County Wastewater Department in Arizona is a large metropolitan treatment plant that on a typical day treats about 60 million gallons of wastewater. Its sanitation system includes 3,500 miles of sewer lines stretching across a 700 square mile area. Now imagine what it takes to monitor and maintain that setup. And just like any other business, the department has a strategic plan that focuses on operational efficiency and public safety. To help achieve its goals, Pima County turned to technology, specifically HMI SCADA, to help double its capacity while operating with the same staff and achieve a 50% increase in overall operational efficiency. If we can move to the next slide, I'll introduce our panel. We have some great presenters today to tell this story, including Larry Sawicki, who's a control system engineer at the Pima County Wastewater Department, Clyde Pace, a practice group manager at EMA, the systems integrator on the project, Brian Farner, senior system consultant with Wonderware West, and Eduardo Bellina, Wonderware InTouch product manager. So let's move to the next slide, and I'll quickly go over today's agenda. So we will start with Larry providing us with some background on Pima County, including the challenges the wastewater department faced. Clyde will also jump in to speak to the project scope and the overall benefits and results. We'll also hear from Brian and Eduardo on what the future of the next generation HMI SCADA looks like. I also want to remind everyone that you can ask a question at any time during this presentation by typing it into the side panel on your screen. We will address all questions at the end of the webinar. So with that, let's move on and get started. Larry will kick off the conversation, and I will start with a question to Larry. Can you tell everyone about the water and wastewater operations at Pima County and explain a little bit about the driving factors for improvement? Larry, over to you.
Okay, good morning. My name is Larry Sawicki, and according to the slide, it says Pima County treats 60 million gallons of water per day, and we have 3,500 miles of pipes across 700 square miles. We have 2 metropolitan treatment plants, 7 satellite subregional facilities, 27 lift stations, and 77,000 manholes. And I'd like to kind of lead in on why and what brought about all of this. In 2007, there was a requirement basically for us to update our treatment processes. What happened was the Regional Optimization Master Plan, and back about 2007, 2008, that began, and eventually a construction plan was produced, and construction began, I believe it was 2009 late, and it went until 2013. We can go to the next slide. The purpose of that was to obtain regulatory compliance to the new standards. And what we found during the development of a SCADA master plan that was produced in advance of the construction at Tres Rios, we found that there was no standardization between several different SCADA systems. 10 separate systems were dissimilar in a lot of ways. So we had no uniformity. And in addition, we were going to expand our system, and we needed to make sure that we presented as well as captured a lot more additional process data.
So let me jump in here. Larry, what were the challenges that you faced in the past that led you to consider creating a situational awareness-based water-wastewater solution?
Well, as you can see from the slide, it says we lacked a wish that was wanted for a long time was for the decision makers, management, et cetera, to be able to see certain information, certain values, information from their wastewater treatment plants. And then the other, we found, like I said, the dissimilars between the systems, too many colors, no uniformity, and again, operator fatigue, and also you might make a mistake because the way they're presented are different. We also had floods of alarms, and if alarms don't have value, and you fail to, and you're not acting on them, well, what's the point of alarms? Alarms should have value, and you must act on them. So again, too many alarms, too many nuisance alarms. In addition, we had, paper and clipboard. This is our rounds sheet. And the thing is, if something was out of whack or something was out of sorts in the process, in the field, and you wrote down a number, you have no idea if necessarily you might not pick up on whether or not that was a problem. And literally walk away with a number on a piece of paper. And if your boss or supervision failed to look at that and say, hey, this doesn't look right, it might just get shelved. And you could be, in other words, it might get missed. So during this, we installed a system which was available to present to our management and decision makers and people evaluating the performance of the facility, a system called WAMS, is what we called it. That was the Wastewater Operations Management System, and the combination of information server and a Tier 2 level historian inside of a DMZ. The other thing we employed was a thing called WAMS, not to be confused with WAMS, but WAMS, which was our wastewater alarm management system. Basically, looking at the performance of our alarm system, it was set up with using a philosophy based on ISA 18.2, and it's running a piece of software called Ureason, and I believe that's a Wonderware partner. And lastly, we used a Wonderware product called IntelliTrack, which migrated our paper-based logging, our logbooks and clipboard for rounds, and made it available within our historian and also at the management level.
Okay. So you had your WAMS and your WAMs, and then you selected the Wonderware technology. Why did you select Wonderware?
Well, scalability. We had a lot of the ROP project for Tres Rios budget was around $200 million for that construction. There was a lot of capital at stake. We had to be assured that the decisions we made would scale and it would work. We needed that level of comfort to know that what we built will work in the end, and that would not be problematic during the construction phase. So scalability was critical. The solution, it says here, is unique because it offers out-of-the-box HMI content. Yes, and also it says here a reusability of the object model. But let me drill in just a little more. The other thing too is during the construction and eventually after we went into commission operation, we needed a level of redundancy we didn't have before. We have a much larger system, twice the size, roughly over 25,000 points in service on that one facility. And we needed something that had levels of redundancy to and failover, automated failover, so that the system's available. We also chose Wonderware to deal with those stranded assets for the rounds. And again, that long-term desire by management for that information sharing for their decision making. And also, why did we choose Wonderware? Well, over the years, we've had a long-term relationship with Wonderware West in Phoenix, Arizona. And so our prior experience and ongoing relationship was a deciding factor as well.
Okay, so on to the project goals. Clyde, since you were the system integrator on the project, I'll ask you to jump in here and describe for us the high-level project goals and scope. What did this entail?
Well, at a high level, we needed to come up with a system that gave the operators an awareness of what was going on in the process, both good and bad. And typically the bad things are what you want to stand out and what the operators need to be aware of. We needed a way to improve the overall decision making. We needed a way for the supervisors and the field operators and the enterprise management to all get the data that they need in a timely fashion so that they can make proper decisions. And then we need to, they have a lot of tribal knowledge at the facility, people that have been there a long time, and their standard operating procedures were just methods in their minds, and we needed to capture those electronically so that they could have a method of developing the future workforce. We also needed to migrate all those systems together. So we had red was go on some plants and green was go on other plants. We needed to standardize into a single application where a control room operator who was looking at all these facilities and all these process areas could understand at a glance what is happening and what is abnormal. We implemented situational awareness HMI displays. We developed displays in coordination through workshops with the county of what standards they want, what colors they want, and we needed to implement these electronic rounds so that they could feed this round data into the historian for decision making. And we provisioned a method for them to integrate system platform with their management software, Maximo.
Okay, and was there anything unique about the Pima County SCADA implementation, Clyde?
The unique part was the visibility of the stranded assets. We provisioned a way and helped install IntelliTrack, which they use to collect their round data, to populate work orders, and to really see what's going on with those pieces of equipment that are not automated and don't have the ability to show up on the SCADA system. We had some cybersecurity concerns. They wanted the enterprise individuals to see what was going on in certain parts of the process, but we didn't want to open up the SCADA system to the internet or to the world, so we are able to utilize this Tier 2 historian to push data to the enterprise so that we could safely share this data with those that needed it. And then the automation of work orders through the historian and IntelliTrack and these methods and information server, we were able to push all this information out and get it to those individuals who needed it.
Okay, so the approach to HMI Situational Awareness, how are HMI displays and alarm management handled differently post-implementing situational awareness?
So the big thing was color, and we came up with a color scheme through a series of workshops, and these were difficult. Everyone had their own impression of what go was or what on was or what stop was, what a high-level alarm. So we pulled all the decision makers together into a room and several workshops and came down with a color scheme that was low in contrast. It was we used different shapes and used numbers for those who were colorblind. We used very bland type graphics, low contrast 2D, so there's nothing to divert the operator's attention away from what he needs to. We had situational awareness principles like unique color and shape. Red is always an alarm, yellow is always a level 2 alarm, things like that. White was always run or on. We put trending and analog displays on all the pop-ups and system screens so that they could identify very quickly what was going on in the system. And then we helped create an alarm philosophy, and we based it on the ISA 18.2 principles. We had collaborative workshops there. We were able to help eliminate those nuisance alarms and come up with a method of distinguishing what was a priority and what was not.
Okay, great. Larry, can you come back into the conversation here and tell us a bit more about the Tres Rios plant? What are the results you have been able to achieve?
Well, it says here the new Wonderware SCADA system has enabled our facility to double capacity while operating with the same number of staff. A 50% increase in operational efficiency with a 10% reduction in energy. So let me lead into and provide a little more detail. During the design, there was a desire to provide an increased use of variable frequency drives in the design. So a lot more, you might say, flexibility in the control of the facility, at the same time leading to quite a bit more energy efficiency when we do operate. The other was also the implementation under the hood of using some advanced process control, model-based control for, say, chlorination and dechlorination, most open valve control or advanced blower control, aeration control. Ammonia destruction control is available if we want to use it to help. We also have a nitrate control. So in other words, we have a lot more advanced control than we formerly had. So we've raised the bar on what we can do in order to achieve A+ quality water production. So the thing, what we see with the use of the Wonderware is the ability to see more of the plant process. There we go. So again, I've led into the higher degree of automated processes that we use. They were planned in and they were executed. The other is making available to the operator more information in more locations at the facility. It leads to the ability to have not only a more productive operator, but it also leads to being able to carry on our operation in the event people retire or things change and we have less staffing. We're generally able to carry through and carry our job and do our business. So and because of that, over time, we make effective use of our money and lowered our operating costs. So that is being looked at, and the decision makers can look at the cost of what it costs to do business and drill in if things go out of sorts and find what's costing us more today than it did yesterday. So okay, on the screen, you see our screens, you look at the screen, it says there's a distinct improvement when things are going wrong. And if you look at the screen, you go, well, this is bland. Well, it is. It's supposed to be. It's supposed to be sort of, you might say, bland. The thing is, what catches your attention is nothing, unless something is on that screen. Then it's to draw your attention. And why? Probably because you have to act on it. So, by looking at it, it's very easy to see the operating state of the equipment, those little white circles. Everything else is very two-dimensional looking. You might say very plain. But here's the thing, those little white, the indication of those white motor status is that it's on. And not only that, there's a little bit of motion so that someone who might be maybe colorblind can sense or see that there's a little bit of motion there to show them that it's working. And again, you see at the top bar there are red critical alarms. Those actually blink, by the way. They, indicating, hey, there's something very important in this area you must look at right now. And so that helps to allow the operators in the facility, as well as the operator in the control room who oversees it. It gets your attention. The operator then can, in the main control room, can say, hey, there's something wrong here, can call out to the other operator who may not be looking at the screen and get it resolved quickly. You might look that, the other thing too, notice that we use very 2D sort of graphics, very simple elements. you know, you know, what is it we're trying to achieve, right? We need to control a facility, but, you know, all the fancy color, 3D graphics, you know, all that's very nice. But what is necessary? What is needed? Where's your focus got to be? Operators do not want to be distracted. If you distract them in some way, it'll get their attention, and they know that something that gets their attention, they have to usually do something with that. So the thing is, you know, you might say, you look at this, you see how much we have there? That is the entire back end of our plant. Our entire secondary process is shown on that screen. The control of it is all shown on that one screen. So the use of high-resolution graphics, effectively coupled with simple symbols, allows us to show and make effective use of the screen real estate. Alarm improvements. As I mentioned earlier, that we used to have floods of alarms, and they had no value. And again, if they have no value, why are they there? If they have value, we run the risk of missing something. So, you know, the whole idea here was to analyze what was happening and how we can fix it. So we brought into play a tool to analyze what was going on during the construction that was revised as to what alarms were reported and how. And then also eventually at the very conclusion of the project, an alarm philosophy document was produced by the project manager describing the methods that we should follow to, you might say, keep our alarm management system and alarms in general, how we must manage going forward. So in other words, actionable alarm management. As you notice here on our screens, we're showing you pictures of 3 different systems. And the thing is, you might notice, well, okay, what's running and what's not? What are those little blue boxes for? Okay, what is that? How do you read that screen? You know, left to right, top to bottom, or does it go in a circuitous route through the screen? And the other system is left to right, top to bottom. I mean, in other words, the way it's laid out, the way it's presented, we didn't have uniformity. The other problem with that, even though you might be trained, you know, on the various different systems, it's very easy to make a mistake. You know, so having a level of uniformity does a couple things. Prevents an operator error by understanding, you know, misunderstanding a particular screen on a particular system, but at the same time, going forward to train new operators. This way, you can train the operator on the symbols or things that you present, and it's done in a uniform way, and they know when they look from system to system that it's uniform, less risk of a mistake, but at the same time, you could spend more time during the training to focus on control of the process. How do you control the process? What does the process do? And the operator values that. So we can spend less time on how do you work the HMI and more time on how do you control your facility. One of the other things too we found was tagging between the systems. Remember, these systems were built over time by a lot of different parties. So what we were left with in the end were systems with different tagging conventions. And that we needed to solve. In other words, come up with a plan early on and say, this is the way we're going to do it. And we're going to carry this out throughout our enterprise. It helps in a number of ways. And so we looked at an abbreviation for the facility. In other words, the flow stream. In other words, in this case, PS, primary sludge. What kind of equipment is it? Well, it's a pump, PMP. So we have abbreviations, and then again the loop number. And that loop number, if you break it down, 04 is the actual plant area, followed by process unit, you might say process unit number 18, and then the unit number 101, and then what parameter is it from that process unit? It's the FIT, an ISA abbreviation for a flow transmitter, an indicating flow transmitter. So again, we came up with a very nice convention to apply. We then applied it at Tres Rios. We then followed on with more projects that, again, followed a tag convention. And when you use system platform and you create your objects, they wind up in your historian. So it's very nice with the tools used with the historian to be able to search by facility, or you could, in other words, it lends itself to searching down information found in the a Tier 2 historian or at the Tier 1 historian. So, lastly, control room operator training. As you can see, that operator has plenty to look at. And you can see there on the consoles in front of them, the smaller screen is actually our older systems. The newer systems are shown up on the big or larger screens. And again, we have encrypted tunnels, basically VLAN, I should say encrypted tunnels to all our satellite plants, as well as a fiber optic, fully redundant network. In other words, the redundancy is at the network level is redundant, as well as a cybersecurity implementation in our facility. Basically a defense in depth to where everything is segmented. Anyway, as for the control room operator training, in other words, we want to make best use of that training. Okay, there's a lot to learn for the operator, and we can spend less time on how does the HMI look and how it's perceived. So I'm sorry, I got a little off track, but there we go. I think I'm done with this slide. And then lastly, I think we're going to system maintainability. When we started this at Iron Row, which became Tres Rios, we had about 1,500 displays. Most of them were trends. About 500 or more were just trends. And then we had a goodly number of pop-up windows, and then process overviews, and actually several process overviews because we couldn't fit everything on the screen. So again, in this system, you'll notice that what was done is the basic controllers in the main pop-up window. There will be a button usually for settings, if they have settings. You'll notice that the top tabs, there will be Oper for operation, alarm, where you can actually select or inhibit alarms from that device or process, and then maint. And what maint does, that provides us like the loop number, things needed for the instrument people. What scan group is it in? In other words, we divvied up the redundant DI objects into separate pieces for scanning PLCs. Where does it live? So that's helpful for the maintainers like ourselves. And we even provision a place for information related to asset information in there for Maximo, if we decided to implement it. So again, and again, these graphics, most of the time they were reused time and time again. So that's what I'm saying. So the system platform lent itself to keeping, again, uniformity in the way the control pop-ups are presented. There we go.
Well, that was a great overview, actually pretty in-depth overview, Larry. And I think we've gone through all the benefits, have we, or is there another?
We can move on to situational awareness.
Okay. So let's switch gears here. I'd like to invite Eduardo to give us a high-level overview of Wonderware's technology. Eduardo, can you explain what situational awareness is and what are the various use cases?
Yes. So In the last few minutes, you've heard a lot about how Pima County used situational awareness approach to improve their processes, some of the concepts behind it, and of course, he mentioned very, very well in very good detail the benefits that they have obtained from applying the situational awareness approach. And what I would like to do right now in response to your question is to leave our audience with a good idea of what situational awareness is, to round up the concepts that Larry mentioned in the previous moments so that they can walk with a good idea of what situational awareness is. Situational awareness is an optimal level of alertness, of consciousness that an operator can achieve in relation to an operation or process. It is a level where the operator can not only perceive information, but comprehend its meaning and project the impact on the process, which allows him to make the best decisions for a successful, safe operation. Now, in simple terms, basically, this is achieved through a design methodology that we call situational awareness methodology, which is oriented to deliver an HMI application that efficiently communicates the true status of a process to the operator. As you saw in the case of Pima County, they optimized the application to a point where they could convey the information they needed from original 1,500 screens down to 50 after applying the situational awareness approach. That's a very good example of how you can make an application optimize and efficiently communicate to the operator. Now, what you do in this situational awareness methodology, the secret is that you place the human being at the center of the HMI paradigm. You make the HMI work for the human being and not the other way around. And you do that by leveraging the strengths of the human mind, such as our ability to associate meaning to colors, to size, to shapes, the human's ability to recognize patterns, to comprehend data when you provide context, etc., but staying away from the human weaknesses, such as our limited ability to deal with large amounts of data, getting distracted by unnecessary animations, our difficulty to understand raw data without context, etc. And to design this type of optimized, efficient applications, you can use the wide range of features and tools in our Wonderware software, such as our alarm aggregation, alarm severity, alarm borders, element styles, numeric styles, trend pins, orchestrographic wizard, and more. And you can design your own graphics keeping situational awareness in mind, or to speed up the design process, what you can do is you can take advantage of the out-of-the-box library of situational awareness symbols that come with our product in combination or in addition to our extensive set of features. And this is exactly the philosophy that was applied by Pima County. So what you see right here is what is situational awareness. Well, while it is mostly it's an HMI design philosophy, it actually leverages the other things that we have right there. As I mentioned, we have an out-of-the-box symbol library that helps us speed up the development process, but we have a comprehensive set of tools that help you build something if you want to build your own symbols. We have extensive alarm capabilities that help you do, as Larry was mentioning, deliver actionable alarm management rather than just a cascade of alarms. And we have the ability not only to record history, but to combine historical data and also get information real-time, combine historical with processed storage and retrieval capabilities. So in reality, it is a HMI design philosophy, but it can do or includes components from all of the above. Now, I mentioned one key thing here. As I said, you can design your own graphics, or you can leverage all the work that we have done, the hundreds of hours that we have spent designing situational awareness library of components, which is a very extensive library with many different components that are typical of different industrial processes. And each one of those are designed as what we call wizards, which are highly configurable, so that each one of those can be configured many different ways, which gives you a total of more than 1 million unique combinations. So this library equates to having more than 1 million individual graphics if you try to do it a different way. Just these 80 wizards can be reconfigured many different ways. One example of a graphic where you can combine data in context is what we're being displayed right here, and we can combine historical data with real-time data. You can provide trends that not only put data in context when you provide the limits, the range, the operating range, the settings information in one single shot, but if you add these little pen trends, it helps you also project what can potentially happen, and many times you can actually be ahead of abnormal situations, even having the opportunity to address some trend, some action that is happening before it actually becomes an alarm condition. Now, you can use this type of approach all the way from one simple HMI, basically in every HMI project that you want. But the larger the project, the more benefit you can reap out of these techniques, because you will be able, you need to bring a lot of data into one screen. Large distributed networks, large plants, water, wastewater, SCADA systems can benefit greatly from this. But again, this is an approach where putting the human at the center of your design makes sense even for a small application. As we can see right here, some typical success metrics using situational awareness. Larry mentioned some that apply to their results, where he mentioned 50% capacity increase and 10% energy reduction. So right here, we are seeing some other examples derived from other experiences. So typically, you see a productivity increase, improvements somewhere between 10%. It depends on your application. The operator awareness, your ability to respond to abnormal situations is sped up multiple times, 5 times as faster that you can react. And engineering, you can reduce your cost in developing this type of applications by using our tools and the out-of-the-box content that comes with it, designed with situational awareness in mind. And now I will transfer to Brian.
Thank you. So Brian Farner from Wonderware West. Larry, by the way, thank you very much for that nice compliment. I'm glad we were able to be part of this project. Now, Wonderware West has a large install base of water and wastewater customers. But one of the common things we've been hearing year after year, actually in recent years, is that municipalities and water agencies are being asked to do more with the same or sometimes shrinking budgets. And so this means there's initiatives to control costs, and really the major costs in this industry are energy, labor, and total cost of ownership. So for the initiative of energy savings and really chemical usage savings, Wonderware, along with Schneider Electric, has an end-to-end energy management solution, from the metering in the field, the VFDs in the field, to our robust data collection and our historian, to our dashboarding, reporting, and analysis to get better visibility into energy consumption, chemical consumption, so you can make changes to improve your process. And then further services like performance contracts and energy analysis provided by Schneider Electric. Another trend, and Larry highlighted on this, is the need for increased operational efficiency. So there's an aging workforce. A lot of people are retiring. It's harder to bring in new talent, so less people are being asked to do the same job and sometimes additional jobs. And solutions like the Situational Awareness Library from Wonderware help make the tool more effective. So a single user can do more. Like Larry was saying, we can see the entire system at a glance. And as we navigate through the system, it's showing this data in context, allows us to have more visibility into the system. They went from 1,500 screens to 50. That's a pretty significant change. through 50 screens, they can see their entire system. But then things like digitized rounds, taking those clipboards and turning them into digitized rounds using the IntelliTrack product helps us take that tribal knowledge and turn it into more institutionalized knowledge. So a new operator can come in and do the same round that someone who had done it for years can do. And they're led through the process so that they're less apt to make mistakes. And then digital or electronic standard operating procedures, solutions like workflow, really allow a smaller staff to do the same work. Pima County's operational efficiency of 50%, that's very exceptional, and that's, I think, a tribute to the work they did in the workshops, but it's not uncommon to take these approaches and see at least 25% efficiency. And then last but not least, total cost of ownership. Wonderware has a proven history of a reduced cost of ownership. From preserving the engineering investment, basically we can upgrade year after year as operating systems change, hardware changes, network topology changes. There's no re-engineering. You just move the application forward and leverage what you already built into the future. And then more advanced functions, like basically coming in and having architecture discussions and leveraging some of the power of the system platform, not having to re-engineer, but basically reuse what you're doing and use it in a new way. And we typically see customers realize about a 20% cost of ownership owning a Wonderware Schneider solution. So Wonderware's been a great solution for water and wastewater for a long time now. But with the complementary offerings from Schneider Electric, we have end-to-end solutions to go from the devices in the field all the way to the dashboard sitting on the city manager's desk. And really, it's a great story. It's a great solution. So just to recap the situational awareness approach and really where it's a good fit. We see it's a good fit for not just water and wastewater customers, but really most industrial customers that have an aging workforce and personnel constraints. Because a lot of what we're seeing is people are retiring, and it's harder to bring in new talent and harder to train that talent. So taking in a situational awareness approach allows them to have a more effective tool. And to what Larry spoke about, giving them data in context and easy to understand helps that training process go much smoother. It's great for organizations with centralized engineering groups because we can define some standards built into the objects and the fabric of the system platform, and then leverage those in our organization, carry those standards out, so we don't end up with islands of unique configurations out there over the years. Situational awareness with system platform is great for applications with large I/O count. To what Larry spoke of, we can see a lot more data in context. So looking at a single screen, we can see the entire system, and then we can dive into the kind of the aspects that we need to. And then the system platform itself scales very well. So as they add to the system and they have geographical issues, we can have hybrid systems where we have some of our computing happening in a centralized area, some of it happening in diverse geographically remote locations, and have it act as one big system. Even when we have network outages, we can have independent pieces that continue to function independent of each other. So it's really situational awareness with system platform is great for geographically dispersed applications. And then applications, of course, where a control room is present. So we can have operators, like in the case of Pima County, we have one operator sits there during the day and is able to see the entire system and instruct the mobile workforce to go out and take care of issues. But it's also good where a control room isn't present because we have mobile technologies that allow us to take those same screens and put them on mobile devices and have a mobile workforce. But the situational awareness is a key moving forward, I think, for customers who want to make the best use of their SCADA system. And with that, I think we're ready for questions.
Excellent. Thank you, Brian. So I want to remind everybody that you can ask a question by typing it into the side panel. We already have a number that are coming in, so we'll try to get to them all. If not, we will address them offline. Brian just talked about training the workforce, and I think this leads well into our first question for Larry, which is how would you describe the adoption of situational awareness?
Okay, how would you describe and learning curve into situation? Well, at first, well, you got to remember that people normally, in the course of things, they resist change, right? In other words, like a comfortable pair of shoes. Okay, I know what it is. I've learned it. And now here's something new. Oh, God, I have to learn something new. So there was a bit of resistance at first. In other words, well, that looks boring. I don't like that. There's no colors. There's no activity. You know, so there was a little bit of crying at first with that. But I think what they saw eventually is that they were able to see more. They were able to do more. And the thing is, you know, I'm the controls engineer, and I'm there in the building with the operators in the control room quite a bit. And I can tell you just by looking at it that the way they do their business, the way they may not even have noticed it almost, but there's a distinct change. In other words, now they're able to pick up on things. They notice things more readily. And even though it may be boring, when it does show up that they have a problem, believe it or not, they see it and they act on it. So it's kind of interesting because it kind of sneaks up on you. You say, well, okay, this is my new screen and I'm working with it. And little do they know that actually it's more effective. But you can see it because they go, oh, this doesn't look right. And all of a sudden they're on the radio calling out to them and go, hey, would you take a look at this? This is what I'm seeing. And that's something maybe I didn't see as much before, right? So that's what I'm telling you, that, you know, it makes better use of them. And like I said, it's subtle. And like I said, the resistance to change was there at first. And now they adopted it. It's their tool. And the advantage of the system, too, is with System Platform, the ability to, you might say, use the distributed alarm manager. We have our operational staff that is in that central control room. They're able to put up the entire enterprise's alarms on one big screen. So if anything happens anywhere, they're alerted to it in the control room. And that's on numerous systems all at once. So that helps them in doing their job in the central control room. So that's what I'm saying. They see it. You know, it's just, but again, at first there was resistance, but now it's part of doing business.
And you know, you just talked about one major advantage of having that system platform in the control room. Are there other key advantages that you found in using the Wonderware products?
Well, okay, yeah. The key thing is that from a development standpoint and maintenance standpoint, we're working with the same set of tools. It's all done in the same sort of manner. You know, so from a maintainability standpoint, that is a key advantage to us to keep the systems running. And then ours, driving business performance matter, not operator actions. Well, okay. The key advantages that I see with using the Wonderware is the robustness of the system, the fact that it's distributed well, and there's automatic redundancy now built into it. Okay, so from a maintenance and actual operational point of view, it's a reliable product in my eyes, right? So that's what I'm saying. You know, so that was, you might say, the key features I see in the Wonderware.
Okay. So, Larry, another question for you. I think there's going to be a lot of questions for you. Who takes ownership of day-to-day life cycle management of the system? Is this handled internally by Pima County, or do you need a technical expert like EMA?
Okay, well, at Pima County, in regional wastewater, we have a department that exists, and we call it the SCADA department. And that SCADA department handles, is at a level to where it can take on projects from either our conveyance division or treatment division, because we have SCADA systems on both. And we have people within our group who have been trained by Wonderware, and we've had training from our control systems integration firm EMA, who has provided us training on their preparation of the various templates and things they produced in our system platform implementation, our application. So they've trained us, so we maintain it on a day-to-day basis. We make necessary changes, we adjust requests for changes ourselves. Now, when we have other projects, like we are expanding on our master plan, our roadmap, and EMA is a consultant to us on those projects, so again, we work with them, and occasionally, yes, there's a question for EMA, and if it's of a very technical nature, to where it's more in the scope of, the performance of Wonderware specifically, then yes, Brian's getting a call, or Wonderware West out of Houston. So in other words, we'll reach out where it needs to go, but day-to-day maintenance, we take care of it ourselves.
Okay. Since you mentioned EMA, there's a question that came through that looks like it's for Clyde. As an integrator, Clyde, what are the biggest advantages you see from using Wonderware?
Well, it's extremely open and configurable. You can take the system and manipulate it to the client-specific needs, and at the same time use out-of-the-box tools to do that. So you're not doing a lot of custom scripting or custom development. You're just configuring the tools that they give you in the proper manner so that the client, in this case Pima County, can use it. It's also very very versatile. You can connect it to different controllers, process controllers out in the field. In Pima County's case, they use Rockwell's Allen Bradley PLCs. So we were able to configure it, and the drivers, which were very easy to set up to talk to, any kind of field instrument that we need. So it's just a very open software, easy configurable.
Were there any challenges or obstacles in the implementation, Clyde? And if so, how did you overcome them?
Absolutely, there's always challenges. So, the biggest challenge was following the construction schedule. We were replacing a legacy SCADA system and at the same time implementing new process features into the system. So the way we did this is we were able to work with Pima County to set up a redundant system, a parallel system in there, so that they had the legacy InTouch SCADA system and the new system platform SCADA system up and running side by side, and they were able to see the differences, the changes, and also bring in the new processes as they were cut over. But it was a lot of coordination with the county, with the operators, with the contractors, and all the other systems integrators, as far as their little package systems to get this to work. So there was a big challenge there.
Okay. We have another question for Larry. Are you presenting data to users outside of the SCADA system on the business or enterprise network? And if so, what is it, and what methods are you using to do it?
Yes, this was desired for a long time. Basically management, people downtown, people, other managers just wanted to know what's happening with their plant, what's going on. They wanted to be more a part of the process at times, or maybe they wanted to compute the cost of their process. So what we're using, here's what we did. We formed what's called a demilitarized zone, a DMZ, and one side of that faces the business enterprise, and the other side of that DMZ faces the SCADA. That's done with that's done with ASA firewalls, Cisco ASA firewalls. Inside that firewall area, I believe there's a set of virtual servers. That's one thing. An advancement with Wonderware was the fact that they've now certified that you can run it under VMware, which makes really nice, efficient use, and also a level of replacement redundancy. In other words, should it fail, you can replace it almost instantly, within seconds. So the thing is, this virtual server farm exists within the DMZ. Inside there, yes, there are some hardware servers. However, you know, there's a historian, a Tier 2 historian. So on the SCADA side, we have a Tier 1 historian with an enterprise license that's performing replication. And then on the SCADA side, there's a, you might say, a path through defined in the firewall so that it will communicate from the Tier 1 historian on SCADA into the Tier 2 historian inside the DMZ. Inside the DMZ, we have Wonderware Information Server, and that implementation, once it was prepared and the applications prepared by EMA for presentation of reports and such on Information Server, it was called WOMS, in our case, Wastewater Operations Management System. And then we set up accounts on there for the people that had a need to access it. So from their desktop, from their browser on their business desktop, they can log into WOMS. Once they're there, they could bring up trends. And what we're doing is we didn't want a constant replication feed, and we didn't need it. So what we were doing is we took 5-minute snapshots of the process data, a good bulk of it, and replicated it into the DMZ historian. Still at 5-minute increments, that's plenty enough to make your analysis whether or not things are on track, and also to determine if your costs are where they want to be. And so a number of reports were prepared and deployed onto Information Server. They could pull those up on demand, and then we also have schedule reports. So overall, that is the mechanism. In addition, we also added something called Dream Reports. So now we have people producing reports for the organization. And again, we're using that product as well in conjunction with the Information Server. So that's how we pulled it off. Yes, the magic of DMZs and all this fancy hardware and virtualization, we're now able to present it with a level of security and confidence that at least our SCADA enterprise is kept safe. Okay, so.
Okay. So we have a few more minutes left, and we've got a lot of questions still coming in. So if we don't get to your question, I want to remind everybody we will get to you offline. But Larry and Clyde, there's questions about optimizing alarm management. Did you follow the ISA 18.2 process, which I believe is the alarm management standard? And what were the biggest challenges and lessons learned from that process?
So I'll take that. This is Clyde. We did follow the methodology. We didn't follow the process exactly because of the constraints in the project and how we entered into it, but we hit all the steps. We did an audit. We created a philosophy. We came back and finalized that philosophy and delivered it at the end, and then created a maintenance plan, which they follow. The second part of that, the biggest challenges and lessons learned. The biggest challenges was sorting through all the data before we had the tools to do that. So we were sorting through just thousands of alarms to find out who the bad talkers were, the frequent talkers, who were the bad actors that came up, and what was really an alarm. And then presenting this to Pima County the operators and the SCADA management personnel to identify, okay, what's really an alarm? What's really a higher priority alarm? And we had to define those priorities. Is this a compliance issue? Is this a health or safety issue? Or is this just a warning that you might need to take a look at this in the next couple of days because this piece of equipment or device may fail? So it was just the amount of data, sorting through it and presenting it in that method was probably the biggest challenge. But after we were able to do that and go through this method with them, there was so many benefits, and we were able just to reduce the amount of alarms, reduce the amount of bad talkers, and really optimize the system so that now they were able to understand what was causing this alarm. Why was this a bad talker? Did we have a problem with the process, or do we have a problem with the instrument? So it was very beneficial and a very good exercise, I think, that we were able to go through with Pima County.
Okay, great. Well, I'm sorry to say we have reached the top of the hour and we are out of time. We still have many questions to answer, so we will address those offline. I want to thank the panel. What a great conversation. And I want to thank everyone for joining us today. If we do not get to your question, again, we will follow up with you. Also, this webinar has been recorded and will be available on demand in another 24 to 48 hours on the Automation World website. Thanks again, everyone, for joining us, and have a great day.